Hello to everyone. You are welcome back to the channel. In our previous lesson, we looked at how to solve or reduce our linear coefficients into homogeneous functions. So that was the first case. And we are going to look at the second case where our a1 over a2 is equal to b1, is equal to b1 over b2. So if there's a case like this, there's a way we attempt that. So I'm going to do an example in our next slide. Okay, so the question is x plus 2y plus 3 dx plus 2x plus 4y minus 1 dy being equal to 0. So let's check and see. Our a1 is 1, our a2 is 2, our b1 is 2, and our b2 is 4, which also simplifies to 1 and 2. So it means they are equal. And if that be the case, what we are going to do is, since we can see that this right here is a factor of this. Okay, so I can say let's let z be equal to x plus 2y. Okay, if we do that, then we can now see that we can differentiate z with respect to x, and we get the z dx to be 1 plus 2 dy dx. And now we are going to try to make dy the subject here. So first we multiply through by dx to get the z being equal to dx plus 2 dy. And making dy the subject, we are going to end up with dy being equal to dz minus dx all over 2. So I'm going to name this my equation 2, and I'm going to name this my equation 1. So I'm going to substitute this z and dy into my main equation, here, to my main equation. So let me rewrite it. Let me rewrite it here again so that we see what is happening. So we have x plus 2, y plus 3, dx plus 2x plus 4y minus 1 dy equal to 0. So I am saying that I have written this as z, so I get z plus 3. I write my 0 dx. And since this is a factor of this, I can write this as 2z. Okay, then I get minus 1. And let's not forget, my dy was also dz minus dx. Let me write it well. Dz minus dx all on 2. So it's equal to 0. Then we try to solve it. So I'm trying to eliminate the fraction, so I'll multiply through by 2. So multiplying through by 2, I'm going to get 2z plus 6 dx, and this becomes 2z minus 1 times dz minus dx being equal to 0. Then I can expand it, and I'll have 2z plus 6 dx plus 2z minus 1 dz minus 2z minus 1 dx, 2z minus 1 dx being equal to 0. So I can see that I can do some manipulations here. We have dx and we have dx, so I can combine them and write this 2z plus 6. I'm bringing this one here, so this one becomes minus 2z and plus 1. Minus minus give me plus 1 dx. I have plus 2z minus 1 dz being equal to 0. And use another color. So you can see that 2z cancels 2z, and I'm going to have 7 dx plus 2z minus 1 dz being equal to 0. So let's go to the next page and see how we evaluate it. So we have 7 dx plus 2z minus 1 dz being equal to 0. So I'm just going to integrate. Okay, so I'm going to integrate each term. So I'm going to have 7 dx is just going to be 7x plus integrating 2z, I'm going to get z squared. Integrating minus 1, I'm going to get minus z, and they are all being equal to c. So at this moment, we can just go ahead and substitute the value of z into the equation. So fx 7x plus x plus 2y squared minus x plus 2y being equal to c. So you can then try to expand, or you leave it as this. So this is how you solve it when we have the second case. That's when we have our a1 over a2 to be equal to b1 over b2. Okay, so thank you. See you next time.